Another very important parameter is the efficiency of the battery. How do we define efficiency in the case of the battery? Is it power or energy? See, normally efficiency is defined in terms of power, output power by input power. But in the case of the battery, we consider energy, watt hours. So consider, for example, a PV source and a load like this, and let us say energy travels from the source, the PV source, to the load in this fashion, and there is a watt hours which is coming out of the PV, and we will call it as WHPV, and there is a watt hours which is going into the load, and we will call it watt hour load. So in this case, in this type of a topological connection, the watt hour PV will be equal to watt hour load, as there is no loss in between except for the transmission. When we use a battery, the energy from the PV is stored into the battery and then released later into the load. So if we consider the case of energy storage element, let us say a battery in this fashion here, let us put a battery. The flow of energy is in this fashion. You have energy flowing from the PV source into the battery. Now this is called charging. So we charge the battery with the energy coming from the PV. So in charging the battery, we are converting the energy from the electrical to chemical, and there will be conversion loss. So we will call this as WHEC, electrical to chemical, WHEC. So there will be this conversion loss, and therefore what will be available within the battery is slightly less than WHPV, what has been taken from the PV panel. And we will call the battery that is stored in the energy that is stored in the battery as WH and that is equal to WHPV minus the conversion watt hours EC, electrical to chemical conversion watt hours. So that much amount is lost. Then the energy that is stored in the battery is discharged into the load as and when required. So the flow of energy, the direction is like that. Now this flow from the battery to the load is called discharging. So we discharge the battery. Now in the process of discharging, energy gets converted from the chemical to electrical, and therefore there will be chemical to electrical energy conversion loss, and we will call it as WHECE. And what is actually available at the load would be WH battery minus WH chemical to electrical energy conversion loss. So you have a loss during the charging portion, WHEC. You have a loss during the discharging portion too, which is called WHCE, and these two have to be subtracted from the original WHPV that has been generated or given from the PV panel. So what the load will get would be lesser than WHPV, and that in effect leads to our definition of efficiency, and it is in terms of energy efficiency, in terms of the watt hours. So watt hours given to the load divided by the watt hours generated from the PV source or any source. We can now write down the efficiency as watt hour delivered to the load by the watt hour drawn from the source. Referring to this figure, we see that watt hour delivered to the load is this portion, WH bat minus WH chemical to electrical energy conversion loss, and WH drawn from the source. This is the WH drawn from the source, which is WHPV. So we can write it as WH bat minus WH CE divided by WHPV. We can further expand this. WH bat can be written as WHPV minus WH electrical to chemical conversion loss minus WH chemical to electrical conversion loss by WHPV. This would be the definition of the efficiency in the case of the batteries. It is dependent on the energy, that is the watt hours, so it is also called as the energy efficiency or the watt hour efficiency of the battery. For most batteries, this efficiency, which includes both the charge and the discharge cycles, watt hour electrical to chemical loss and watt hour chemical to electrical loss, one during charge and one during the discharge, is being included into the efficiency equation. And this efficiency is generally around 70% for most batteries. The lead acid batteries that we commonly use is roughly about 70% efficient, energy efficient. Likewise, the nickel metal hydride and some of these lithium polymer batteries also have similar kind of efficiencies.